Housing starts rose to a 20-year high in November, according to a new government report.
Peak load
The
driven by
increase is
hot weather
attributed
and
to
excessive demand appears to be a culprit in the power
Hurricane
blackout
Katrina
affecting
is
a large
expected to
part of the country.
significantly raise the cost of natural gas used for heating
Energy-efficient
throughout the
building
country.
codes are being adopted in many states due to the high demand and
The
high
new
cost
energy
of energy.
bill gives homeowners a tax credit for using new low-E replacement windows.
"20 years ago, low-E coatings were developed as a way to make better insulating windows and reduce heating costs. These first-generation low-E products allow the bulk of the sun's heat to pass directly into the building. Today, this type of glass is called high solar gain low-E. Advances in coating technology have resulted in a next-generation product we call low-E squared. Low-E squared insulates during the cold weather and blocks a significant amount of solar heat in the summer. This low solar gain product saves energy in the winter and can play a significant role in reducing total energy costs because it saves on cooling as well.
Cardinal Glass Industries, in an effort to verify the energy savings of their low-E products, built 2 identical homes in Roseville, California. Then 3 identical homes were built in Windrose, Texas, followed by the building of 4 identical homes in Fort Wayne, Indiana. The goal was to monitor the home's energy costs in each climate when outfitted with clear glass or high solar gain glass compared to new low solar gain low-E squared glass.
The concept behind the Roseville project was to buy 2 builder houses with clear glass, operate them side by side to prove they're identical, then switch out the glass in one house to low solar, low-E, high performance glass and measure the energy performance difference.
Roseville, California was chosen for a number of different reasons. First is that California's a very large construction market and there's lots of building going on here. So demonstrating that these products work in a California type environment was probably a good idea. Second good reason to choose Roseville, California as a test location is that it's a unique climate and that it has about equal amounts of heating and cooling.
I got involved in the Roseville project as the technical supervisor, and my job was to figure out how to make sure we had the houses built right and instrumented correctly so we could understand what the results were and we're sure we knew what we were measuring.
In our first phase of testing at Roseville, the energy savings matched the computer simulations.
The cost savings results in the Roseville project amounted to a 27% reduction in the cooling bill. In addition, the heating bill showed a savings of 10%. Another goal of the project was to validate that using a smaller air conditioner in conjunction with low-E squared glass could reduce the peak power demand that occurs in the late afternoon when homes have been overheated throughout the day. At Roseville, the use of low solar gain low-E squared glass and replacement of the air conditioners with smaller units of the same efficiency reduced the peak power demand by 33%. This showed that the builder could save money on initial equipment costs, while the smaller air conditioner reduced strain on the electrical power grid.
When we're working with our builders on design of their homes, the window products are the first thing we recommend an upgrade into a low-E squared product. The load calculations clearly show a benefit of those glazing products, and the air conditioner size will come down, which has many benefits, certainly in energy consumption, certainly in peak load reduction.
You know, the most important outcome to me of the Roseville project was proving in simple terms, looking at a typical production house built in a very popular area in California, to demonstrate that in fact these products can make a significant difference on both the cooling energy use and that peak demand.
In the next phase of the study, 3 identical homes were built in Windrose, Texas.
South Texas has a very long cooling season and very high humidity. After construction was completed there, tests were done to confirm that all 3 homes were operating at the same efficiency. Duct blaster tests confirmed identical airflow, and lower tests quantified the tightness of each home's envelope.
In the Windrose project, there are 3 houses identical, 1,800 square foot, 3-bedroom, single-story houses with 3 different kinds of glass. One has single gray glass, one has double gray glass, and the third house has low solar, low E squared high performance glass. Each of the houses is equipped with a data logger which records the performance of the house on an hourly basis, or even in some cases on a minute-by-minute basis. Each room has a temperature sensor that's recording the room temperature, and we have a complete weather station outdoors that records the outdoor temperature and solar radiation and humidity. We have careful measurements of humidity in the houses and in the air conditioning system, and we have temperature data on the air conditioning system, which along with measured flows allows us to estimate the actual cooling energy delivered on a minute-by-minute basis.
The low E glass has actually changed the way we look at load calculations. The numbers are coming out lower than what we've ever seen before, so we're having to downsize our tonnage, which saves everybody money on the initial size of the unit, plus it saves on the monthly energy cost. It's very important that the windows be good quality, because in our area, especially in Texas, the solar gain from the windows is the most dramatic effect on the house.
The use of low E squared glass in Windrose, Texas, demonstrated similar results to those in California. The savings were over 26% in cooling costs and 33% in peak power demand when a smaller air conditioner was used. Another benefit of low E squared